The water cycle begins with evaporation. This is when the water from any body of water, such as a river, evaporates, meaning that the water turns into water vapor, and it then creates a cloud. Once it's formed into a cloud, the step is known as condensation. Once the vapor is turned into a liquid and either rain, sleet, snow, hail, or freezing rain fall from the cloud, the step is known as precipitation. When water precipitates, it goes down onto a hill or a mountain, and from there the water goes into a body of water. This step is called the runoff. The runoff is what keeps the cycle going. It then starts all over again, and that's what makes the water cycle.
On Earth we have 4 seasons every year due to the Earth's tilt. To begin, we have spring that goes first and begins on March 20th. During this season, there's all kinds of weather. We can have snowy, rainy, or sunny days. This is when flowers begin to grow and trees turn green again. The sun enters the sign of Aries. We then have the summer that begins on June 21st. During the summer, it is mostly all sun and nice days. This is when the sun enters the sign of Cancer. After summer, we get into fall, also known as autumn, and it begins on September 26th. During the fall, leaves begin to fall off the trees, and it gets a little colder, and our nights become longer. The sun enters the sign of Libra, which makes autumn. Last, we have our winter, which starts on December 21st. Everything gets really cold, and we have lots of snow. This is when the sun enters the Capricorn sign and makes it winter. And those are the 4 seasons. There are 4 layers in our atmosphere. To start off, we have the troposphere. This layer is the closest to the Earth's surface. It contains about 75% of the atmosphere's mass. Warm air from the Earth's surface rises, and cold air above it rushes in to replace it. Temperature and pressure drop the higher you go. Next, we have the stratosphere. It lies directly above the troposphere, 35 kilometers deep. The lower portion of this layer has a constant temperature with the height, and the upper portion of the temperature increases with altitude that is caused by the absorption of the sunlight by the ozone. Okay, then we have the mesosphere, directly above the stratosphere. It extends from 50 to 80 kilometers above Earth's surface. This is the cold layer where temperature decreases with increasing altitude. It is thick enough to slow down the meteors coming into our atmosphere when they burn out. Finally, we have the thermosphere, 80 kilometers above the Earth's surface in outer space. The temperature is extremely hot and can be higher than thousands of degrees. As several molecules occur in the thermosphere, we receive huge amounts of energy from the sun. And those are the 4 layers of the atmosphere.
There are 3 types of heat transfer. Conduction, which is like frying an egg. Convection, which is like warming a room with forced warm air. And radiation, which is like getting a suntan or a sunburn.
Water vapor, nitrogen, oxygen, and carbon dioxide are the main gases in our atmosphere. Water vapor is a small amount but very important because it is one of the main sources for clouds which help to cool the earth. Oxygen is big to chemical reactions which is helping burning anything flying to our atmosphere such as meteors. Nitrogen is significant for proper growth, development, letting anything get sources of protein and nutrients. This is an example of how nitrogen is the mandatory in our atmosphere. The gray is the oxygen and the red is the carbon dioxide and water vapor. In our sky, there are 3 types of clouds: cirrus, cumulus, and stratus. Cirrus is a cloud that looks wispy, or some say like curled hair. These are also the highest clouds in the sky. Cumulus is the middle cloud, which looks like cotton balls and are very puffy. This is the middle cloud. Stratus clouds are the lowest and are very thin, acting like a sheet over land. 5 types of precipitation. They are rain, sleet, snow, hail, and freezing rain. Rain is cold droplets of water, such as this. Hail is frozen balls of ice. Sleet is a mix of snow and water combined, and snow is powdery precipitation, such as that. The last one is freezing rain, which explains itself, which is frozen droplets of water. Last one is air pressure. Air pressure is all over you, pushing left, right, up, and down. To show an example of it, I have this bottle full of water, and there is a hole towards the bottom. No water is coming out because the cap is on and all pressure is equal. But when I take the cap off, water comes out of it because of all the pressure changes and goes downward. When I put it back on, it stops dropping again because all pressure becomes equal again. So that proves that air pressure is all around.
The Coriolis effect is caused by the Earth's tilt at 23.5 degrees and also by the Earth's rotation. The northern hemisphere goes clockwise, and this is the way the water rotates. The southern hemisphere goes counterclockwise, which would be this way. And at the equator, it just stays the same and doesn't move at all. It's stable. And that would be what the Coriolis effect is.
High pressure spins clockwise and low pressure spins counterclockwise, and they work off of each other. So if my sister spins clockwise and I spin counterclockwise, they work off of each other. These are global winds. Obviously, this picture explains most of it. At 60 degrees north, the wind flows upward. 30 degrees north, the wind flows downward. And at the equator, it flows up. It's just a big cycle. There are 4 types of air masses. Continental means land, so it's dry. Maritime means from water, so it's moist. Tropical means from the equator, so it's hot. Polar means from the pole, so it's cold. If you mix them together, like for example, continental and tropical, it means dry and hot.
Climate is all over and is different in many ways. These differences are what affect it, and those are latitude, elevation, mountains, bodies of water, global winds, and vegetation. Latitude goes around Earth. The higher the latitude, less sun rays will hit those areas. This causes less heat and cooler temperatures. It's hotter towards the middle and colder towards the poles. Elevation affects climate by getting colder the higher you go up. Also, depending on how high or low an area is, will determine its climate and precipitation amount. Mountain ranges cause a rain shadow, which will make land under it cooler than the rest. The shadow is caused by cold air rising over the windward side, forming a cloud raining, and the dry cloud on the leeward side is the rain shadow. Bodies of water such as lakes and oceans either cool or warm the surrounding air. This is because the water puts off heat as well, and air above it will change to around water temperature. Global winds create moisture and heat around Earth, changing the climate to warm or cold, all based on the amount of dryness and moisture. Vegetation affects both climate and precipitation. Plants absorb energy and put off carbon dioxide and energy. Tropical climates with many plants are very humid and warm due to many plants.
People consider the greenhouse effect as a blanket for Earth. The greenhouse effect is when sun rays come down to the Earth and when they reflect back to the sun. Some of the sunlight is kept on here. Greenhouse effect keeps the lower layers of the atmosphere warmer and the upper layers colder. There is also the greenhouse gas. It's the gases in the atmosphere that emit and absorb the radiation within the range. The primary gases are water vapor and carbon dioxide. Global warming is the increase of temperature in the Earth's atmosphere. The Earth's atmosphere is overloaded with the heat trapping of carbon dioxide, and this is threatening our climate by changing it and creating dangerous disasters. It can affect your health and animals' health.
The natural things that change the climate are the orbit, the tilt, and the wobble of the Earth. The orbit changes how close we are to the sun. The tilt varies by 2 degrees, which changes the amount of direct sunlight each hemisphere gets. The wobble changes the amount of solar radiation the Earth gets.